Hi guys. So today we are going to start a session on one very popular topic. We could say that related to the integrity of the vessel, pressure vessel, taking the reference of the requirement of UG 99 of ASME BPBC Section 8 Division 1 2015 edition. We will go straight to UG 99 just to see the requirements of standard hydrostatic test. This test we are going to conduct when our vessel is completed with all the entities, required entities, uh, all required testings, and the related applicable heat treatments. So let's just jump to UG 99 directly. Uh, we'll start with uh, the very first and common points. Uh, yeah, I'm just making it a little wider so that you'll be able to read it clearly. So, as we see, UG 99 standard hydrostatic test, the general requirement uh, is a vessel including the chambers or combination unit designed for internal pressure vessel except those tested in accordance with UG 100 and UG 101. So what is 100 and 101? So it refers to the requirements related to pneumatic testing, uh, which we have uh, as available pressure test in substitution of hydrostatic test. Under certain some circumstances, if we cannot perform or if we are not in a position to complete perform the hydrostatic test, uh, we can do the pneumatic test. But of course, there are certain conditions through which compliance we should have a compliance of uh, going further. Yeah. So here, if we see UG 99 is having multiple sub clauses. Like if you see, it has within UG 99 there have a sub clause A, B, C, D, E, F, G, and I believe H and I, that we are going to see later how many total sub clauses are available. I think it is up to, okay, we have M, up to M, which is flange assembly, up to flange assembly. So that is there. Let's just focus on UG 99 requirements. Like if we say within A, of course, it is a general requirement vessel design for vacuum. We have the requirements needs to be followed of UG 99 of subclause F. uh, when pressure test to be conducted, if someone will ask us like when we can conduct a pressure test. So here is the answer coming up from this paragraph. What it says is the pressure test shall be conducted after first condition. There are two conditions. First is all the fabrication and assembly have been completed except for the operations that could not be performed prior to hydrostatic test. Prior to test. such as weldage preparation and cosmetic grindings on the base material that does not reduce the actual thickness below the design thickness. And the second condition is all the examination have been performed except those required after test. So certain tests we can only be able to do after hydrostatic test is done. So so for that still without that examination is done, we can go ahead with the pressure test. What 99b says is what would be the minimum test pressure. This is quite interesting topic for us of today's discussion. If someone will ask you like what is the minimum test pressure for hydrostatic test, what generally we used to say is in general term what we do is we compute, we get the design, we get the hydrostatic test pressure by computing it with maximum allowable working pressure. Generally people used to do like it's in the, it is like about term these days among industry people, like they what they used to say is it is 1.5 times of the maximum allowable working pressure, that is nothing but MAWPA. But it is not like that. If we say what ASME ASME BPVC section 8 division 1, what it says, as per UG 99B, it says that hydrostatic test pressure at every point in the vessel is at least 1.3 times of MAWP multiplied by lowest stress ratio. So now what you have is for yeah, that is again lowest stress ratio for the pressure boundary material which is vessel is constructed from. Like now what you are having the pressure test calculation as 1.3 times MAWP multiplied by lowest stress ratio of the material under construction. So with this you can get the pressure test value. Now what is, you must be aware of MAWP, which is normally be available on the design data sheet of the drawing itself, but you might have not been aware much about LSR, which is nothing but lowest stress ratio. What it exactly mean in this formula? Like, see, for example, if you can recall some of the designs that you might have seen in your in the past, which has say the variety of design, like there is variation into design pressure and design temperatures, or maybe we can say like the service temperature. That particular vessel is subjected to sense at the point of operation. Now, we have the difference in temperature uh, with respect to the temperature at the point of hydrostatic test at workshop, and the actual test temperature, actual job temperature when it is the equipment is into service. So there is a difference into temperature. So for that you are having a limitation, like at certain degree centigrade of temperature you are not going to have exact minimum specified yield strength value, which is taken for consideration when we are having a vessel design calculation uh, or verification of the safe design. So how do you mitigate that? Like, say for example, your vessel is going to have a service temperature of say 300 degree centigrade temperature, and if you look at what strength your material will have when it is having a temperature, when it is heated up to the temperature of 300 degree centigrade. Now if you see the test certificate of the material, what values you are seeing is given at a room temperature. So there is variation. If if the material is at 300 degree centigrade temperature, you are not going to have the same minimum specified yield strength of the material. Just to compensate that, what you do is you calculate the lowest stress ratio, which is by computing the minimum specified yield strength of the particular material at service temperature versus the minimum stress specified yield strength value of the material at the room temperature. So you take the ratio of these two and you will be able to get your lowest stress ratio. And here is the complete description of the same. What it says is the stress ratio for each pressure boundary material is the ratio of the stress value at its test temperature to the stress value at its design temperature. Right. So it is a clear ratio between the the stress value S at test temperature versus to the stress value at its design temperature. So thereby you will get, now what C clause says, it is a calculated test pressure. Hydrostatic test based on the calculated pressure may be used by agreement between the user and the manufacturer. The hydrostatic test pressure at the top of the vessel shall be minimum of test pressure calculated by multiplying the basis for the calculated test pressure as defined in mandatory appendix 3 sub 3-2 clause for each pressure element by 1.3 and reducing this value by static head. The test pressure, the test fluid on the vessel on that element, if this pressure is used, the inspector shall reserve the right to require the manufacturer or designer to furnish a calculation used for determining the hydrotest pressure for any part of the vessel. Subclause D of UG 99, what it say? It talks of maximum test pressure, like how much is the maximum test pressure allowed. Now you are having, since you are having, after calculating the minimum test pressure for hydro test is by computing the expression, which is 1.3 times of MAWP multiplied by lowest stress ratio of the material through by a material of which through which the vessel is constructed. Now, what is the maximum test pressure allowed by ASME Section 8 Division 1 and further by UG 99? So it is given in UG 99D. The requirement of B is what the calculation that you have done here, minimum test temperature. what it says is the requirement of B represents a minimum hydrostatic test required by this division. The requirement of C, what it says, is the hydrostatic test of each individual part of vessel. So, if you see what it says, the requirement of C represent a special test based on the calculation. So you're not doing anything, any calculation like as a lump sum, like oh, you do 1.3 times of MAWP by LSR. But see, for example, you're not having the constant thickness across the vessel. Now, say for example, if you are having a sarin nozzle in between the shell body or dish and body, so you are having a difference into thicknesses. So that is what is taken care by using 99 C. Here further it has been expressed like the minimum test pressure is as per UG 99B and again C, which is calculation based. Further, any intermediate value of the pressure may be used. This division does not specify the upper limit for hydrostatic test. However, if the hydrostatic test is allowed to exceed either intentionally or accidentally, the value determined in C to the degree that the vessel is subjected to visible permanent deformation, the inspector shall reserve the right to reject the vessel. See, for example, you are having the test temperature calculated as say 100 kg per centimeter square. So what you are having the minimum test temperature as 100. Now if it goes say more than that sometimes, so how much over pressurizing is allowed? Over pressurizing, as far as ASME is concerned, they are not limiting manufacturer to having a maximum test temperature, but yeah, of course, that over pressures should also not be capable enough to deform or to distort the vessel itself. If something comes up as an observation by the inspector, it definitely has all the rights to reject the particular vessel if it is the case. Further, E is a supporting clause, like it talks of about, the combination of units. Here, as an inspection, we are not having much to be discussed. So we are here skipping subclause F. No, E. Yeah. So about it, what F says, when the vessel designed for vacuum or pressure vacuum only, the requirement of VG 99F needs to be followed. Single wall vessel or individual pressure chambers of the combination unit designed for vacuum only, MAWP less than equal to 0, shall be subjected to either one internal hydrostatic test in accordance with UG 99 or a pneumatic test in accordance with UG 100. The applied test pressure shall not be less than 1.3 times of the specified external design pressure or vacuum test pressure. conducted at a lowest value of specified internal design pressure in conjunction with the vacuum test. A leak test will be performed following a written procedure complying with the applicable technical requirement of Section 5, Article 10 for the leak test method and technique specified by the user. Leak testing personnel shall be qualified and certified as required by Section 5, Article 1, T120E. Further, UG 99, we have a subclause UG 99G, application of test pressure. Uh, yeah, there are certain requirements given with respect to pressure application when you are having a hydrostatic test into hydrostatic vessel is undergone by hydrostatic test. What method you should follow or you shall follow for apply when you are applying the test pressure. The test pressure shall not be applied until the vessel and the test fluid are at the same temperature. This is very important clause. Like we must check the temperature of the test fluid and the surface temperature of the vessel. It should We should not pressurize the system. We can of course do the fill up of the fluid into the vessel, but we shall not start giving the pressure further. The requirement comes up from UG 99G 1. Then the second point is the pressure shall be gradually increased until the test pressure has been reached. This is bit of very clarified thing. Gradually raise increase into test pressure is advised always. Otherwise we may have to see the deformation or maybe or do a damage. It can give damage to the pressure gauges as well sometimes, and sometimes handling a pressure uh, yeah, more concentrated or maybe the more focused interest is served just to avoid the deformation into the pressure vessel. Test pressure shall be held for sufficient time to ensure that the pressure is stable and there is no evidence of pressure loss. So, just to avoid the false start point of the test pressure, we should wait till the pressure gets stable across the system and we see there is not much or significant difference between two pressure gauges generally, one at the top and one at the bottom. Of course, the static head pressure difference because of the static head we can consider. Uh, the fourth point is if the test pressure is to be maintained for the period of time the test medium in the system is subjected to thermal expansion, precaution shall be taken to avoid the excessive pressure. Yeah. Further, we have combination of units. The combination units having joint that will be visible inaccessible during inspection. The manufacturer and inspector shall consider types of inaccessible joints, say tube-to-tube sheet joint or flange joint or welded joint when determining the test pressure holding time. The test pressure holding time need not exceed 10 minutes unless a longer holding time is specified by the user or user's designated agent. Uh, Leakage, including that from temporary test closure, closure shall not be permitted during the test pressure holding time. Now, inspection clause. Inspection pressure. Following the application of the hydrostatic static test pressure, the test pressure shall be reduced to MAWP and then held for sufficient time to permit the inspection for leakage in accordance with clause 2, which we are having the acceptance criteria. There are two: single chamber vessel, visual inspection for leakage. At the inspection, pressure shall be made of all joints and connection. Leakage shall not be permitted during the inspection, except that leakage from temporary test closure at the opening intended for welded connection to allow allowed, provided the inspection pressure is maintained and the leakage does not mask other joint to be inspected. Combination units. Final and interim pressure test, a visual examination for the leak test, a visual examination, a visual inspection for leakage. The pressure shall be made of all visibly accessible joints and connections. For common elements in combination that are not visibly accessible for inspection, the test may be considered acceptable if there is no loss of pressure and no leakage from temporary test closures during the inspection. The inspection shall also confirm that there is no leakage from visible accessible openings in adjacent chamber. So here after A B we have third acceptance criteria, gas leak test. The visual inspection required by A and B may be waived provided all the following requirements are satisfied. So in place of doing the single chamber vessel or combination unit test, you have other substitute method, which is the visual examination may be waived provided all the requirements are fulfilled. Suitable gas leak test is applied. Substitute of gas leak test by agreement reached between manufacturer and the inspector. All welded seams that will be hidden by an assembly and visually examined and inspected for workmanship prior to the assembly. The vessel will not contain the lethal substance.